Hello everyone. Okay, so Junior Cycle Exam Higher Level Question 8, 2023. Let's get cracking. So, this question required you to convert units, calculate size of angles using trigonometry, and also calculate speed. So, convert 7.5 kilometers into meters. So, there are 1,000 meters in 1 kilometer. So therefore, to convert kilometers to meters, I just multiply by 1,000. So 7.5 kilometers to meters. So 7.5 times 1,000. It's going to be 7,500 meters. Bada boom, bada bing. Easy peasy, lemon squeezy. Right. A plane P took off from the airport. It left the ground at the point T. After a few minutes, it was 7.5 kilometers from T, and it was 200 meters directly above level ground, as shown in the diagram below. Use trigonometry to work out the size of the angle. Give your answer in degrees, correct to one decimal place. So we're going to use trig. So we're going to use one of my trig ratios here because I have sine, cos, and I'm going to use sine, cos, and tan. Right, because I have a right angle triangle here. So what sides do I have? I have my angle here. Well, I have my opposite side, and then I also have my hypotenuse, right? Because remember, hypotenuse is one always across from the right angle. So, oh hell, another hour of algebra. So I'm going to be using sine, right? So sine is equal to opposite over hypotenuse. So sine of angle E is equal to 200. Now, if you look here, 200 meters, right? This is in kilometers. So we either need to write the 200 meters as kilometers, or we need to write this as meters. So I'm just going to do as meters because we had to do in part 1. 7,500. Calculate the angle. I use my inverse. So sine inverse 200 over 7,500. So sine inverse 200 over 7,500. We are going to get then the angle is equal to 1.5 degrees. Yeah, 1.5 degrees. I don't see how my maths would be wrong there. Yeah, 1.5 degrees. That's odd. Unless I'm wrong and someone wants to correct me. But 1 degree. There you go. There you go. There you go. There you go. Let me just test something really quick. So for, I suppose that does kind of make sense, really. Cos inverse. Yeah, that is 1.5 degrees. Who would have thunk it? Right, so 1.5 degrees. Easy peasy, lemon squeezy. Right, so that's a tricky. So that's kind of a little devious one because they want you to question your answer like I did. Right, okay, so that's that part done. Part C, write 20 minutes as a fraction of an hour. Give your answer the simplest form. Well, there's 60 minutes in 1 hour. So be 20 minutes over 60 minutes. And that would be 1/3. So 20 minutes is 1/3 of an hour. So that was a nice, easy part. And then part 2, during part of the flight, plane P travels 598 kilometers in 2 hours and 20 minutes. Work out your average speed of plane P during the time in kilometers per hour. Give your answer correct to one decimal place. So remember, Dad's silly triangle. So distance, we're looking for speed, right? So it's asked us to calculate the speed. So speed is equal to distance divided by time. But he travels 598 kilometers in 2 hours and 20 minutes. Well, we just learned there 20 minutes is 1/3 of an hour. So we can just divide that by 2 1/3, or 2.333333, or 7/3 hours. doesn't really matter. So 2 over 2 1/3. So let me do this now. 5.98. Put it over 7. We are going to get, so give your answer correct to one decimal place. So the speed is going to be 256.2857, but says to one decimal place. So 256.3 kilometers per hour. And that makes sense, right? A plane's traveling that fast. If you got anything slower, I probably would question your maths. But the answer is 256.3 kilometers per hour. So for every hour they travel, they are traveling 256 kilometers. And I think we have one more part here. Part D. In the diagram below, each of the points A, B, and C represent an airport. The plane travels 598 kilometers from airport A to airport B and then travelled on to airport C. Work out the distance AC, correct to the nearest kilometre. So we want to work out this distance here. So we need to think of it now, because I now have two right angle triangles in front of me. So what I am going to do is I'm going to find this distance here. Then I'm going to find this distance here. And then when I add them together, it will give me AC. So for the first one here, I can just use my trig ratio to find what x is. Because what sides do I have? I have my opposite. Therefore, this is my adjacent. So I know tan of 35 is going to equal to opposite over adjacent. So it's going to equal to 280 all over x. X tan 35 is equal to 280 kilometers. X is going to equal to 280 divided by tan 35. So that's my x. Now I want to find this distance here. I can just use Pythagoras' theorem here for this one because I have two sides. So it's my hypotenuse squared. So a squared plus b squared equals c squared. So 280 squared plus y squared is going to be equal to 598 squared. So 598 squared. So y squared is equal to 598 squared minus 280 squared. Y squared is equal to 279204. Y is going to be equal to the square root of that. So y is going to be equal to 528.397. 398 kilometers. And x is going to be equal to 280 divided by tan 35. X is going to be equal to 399.88 kilometers. So recall, AC is equal to x plus y. So it's 399.88 plus 528.398. Add them up. AC is going to be equal to 928.279, but says to the nearest kilometer, so my answer is going to be 928 kilometers, because I'm rounding down. Right, so that's how we do this question. So I found what y was. Y was 528.398 kilometers, and x was 399.88 kilometers, and you add them together to get your total length AC. So there's a good bit of trig in that question as well, and I hope this video was some help, and I'll catch you guys later. Bye.